Math 8. So we're going to talk about slope. Some of you got some of the notes before, okay, but we're just kind of we need a little bit more. Okay, we had a brief intro. Some classes didn't get as much of it, some did. So this video is going to be kind of a breakdown of what slope is and how to find slope on a graph. Okay, so the first thing we talked about is slope is defined as a measure of steepness. Okay, is how steep something is. If I talked about a small hill, pretend this is the bottom of the hill. Okay, a small hill, that's not that steep, okay? But if all of a sudden I increase it like this, it is a lot steeper, okay? So there's a measure of steepness, okay? That being said, you have both positive and negative steepness. The more it looks like a horizontal line, the less steep it is. The more it looks like a vertical line, the more steep it is. Whether it's positive or negative, it doesn't matter which one. This is more steep than this, okay? This is more steep than that, okay? So a measure of steepness is just what slope kind of is in the general sense, okay? For us, there's going to be 4 types of slope, okay? We have positive slope, where I have a graph, okay? We always look at this graph from left to right. It eliminates kind of a variable. The example I used was guessing both my favorite food and my favorite color. If I told you had to guess 2 or just 1, which would be easier? Well, guessing 1 would be easier. Guessing 1 would be easier, okay? So when we think about it, if we always go from left to right, then we know that it's going to be positive going from left to right, and then we just have to think, is it going up or down? Instead of going, oh, is it going left or is it going right, and is it going up or is it going down? If we just say it's going from left to right, and then we just look, is the line going up? Well, if it is going up, that means it's positive. So you notice from left to right, this line is going up. The other one for negative, okay, if the line is going down from left to right, then it's negative. So again, we're looking left to right, it's going down, that means it's going to be a negative slope, okay? The only difference here, one's going up, one's going down, okay? They're basically the same thing when you're thinking about starting at the left, working towards the right, okay? That's the difference between positive and negative, okay? So, next 2 types in 1 second. All right, so our next 2 types of slope is when we're dealing with a horizontal line or a vertical line. Okay, so it's either positive or negative, it has to be going up or down. These 2 are a little bit different. If we look at this first one, okay, let's just pretend that this y value is at 3. It's not the best drawing, but let's pretend it's at 3. That means this line is always going to be at y equals 3. In fact, that's actually the equation for this. You don't need to know that yet, so that's okay. But since the y doesn't change, that means it's not going up and it's not going down. So therefore, it's just a horizontal line. Okay, you know that because it's always at y equals 3. But because of this, if you think about it, a line going up is positive, so like 1. A line going down is negative, so like negative 1. Well, what's between 1 going up and negative 1 going down? Well, that's 0. Okay, so here we call this 0 slope. Some people say, oh, it doesn't have a slope. Yeah, it's kind of the same thing. Okay, but 0 slope. This one is the opposite. Now, let's say it's at 4. So here it's always at x equals 4 going up and down. No matter what, it's x equals 4, which is the equation again. Okay, don't need to know it yet. But that's always going to be x equals 4. Here is kind of tricky. Okay, go back to my marker. If I still have my meter stick, I would use my meter stick. But you would say that this is pretty steep if this was some sort of hill going up. But whether you're at the top or the bottom, if you're looking down the hill, you're like, that's steep. If you're looking up the hill, you're like, oh, that's steep. If it's like this, you're like, it's not really that steep, okay? Again, there's no steepness to this. It's a flat line. A little bit of steepness, a lot of steep. But if it's a vertical line, like if I stood against this wall and I looked up, I can't say how steep that is. It's not going up or it's not, it's not increasing or decreasing. It's a straight up and down line. I can't actually measure the steepness of this because if you think about a hill, the measure of the steepness is how far are you going up the more you climb into into the hill, so to speak. Okay, here it's a lot more steep because you got to go up more the farther you go this way, Here, you don't have to go up as much to get over. Okay, so we can't actually measure this, so therefore it is undefined slope. Okay? Again, pause if you need to write those down, and then we're going to get into the next part. Okay. So the next part is going to be my beautiful graph here. I was going to, pull it up, but I can't really record and pull something up on the screen at the same time. At least now I can't. Okay, so we have this graph. Okay, x is going right or left, y is going up and down. Okay, slope is simply the distance from one point to the next point. Okay, and the way we figure out what that slope is we need to count. Okay, so we'll pretend that there's a line here. We need to count how far it's going up and over. You can kind of see the dotted line version. Okay, and the way we talk about this is it's a ratio. Okay, so going back over here, we talk about slope is actually represented by the letter m. Okay, no matter what, if you see an m in an equation, it means slope. Okay, if there was a 3 where the m is supposed to be, that means the slope is 3. Something we'll talk about again, but that's okay. Okay, if you ask your parents possibly if they remember slope, one thing they might remember is the whole rise over run. Okay, so this is how much is it going up or down versus how much is it going right or left, which again we'll talk about most of the time. We'd say right. Okay, rise over run. Another way we say it is the change in y divided by the change in x. Okay, and again, this is not something that we're going to make weird decimals and stuff like that. It's a ratio. Okay, if I said what was the ratio of boys to girls in the class and it was like 3 to 2, you would say 3 to 2, 3 boys to 2 girls. You wouldn't say something like 1.5. Okay, it's a ratio. You need to be able to compare the change in the y to the change in the x. Another way you're going to see this is with a little triangle. That triangle just means change in. Sometimes it's called delta. Okay, it just means change in the y, change in the x. Okay, one way you're going to see this is with a formula, which we're not going to do yet. Okay, we're just going to solely focus on from the graph, which we're going to do here in a second. Okay, so pause if you need to. Otherwise, we're going back to the graph. So back to this problem that we had. We're always going to go left to right. Always left to right. That way we know that the bottom of our fraction, so m equals the change in y, change in x. Okay? We know that the bottom is always going to be a positive. The top is going to be positive or negative. If it's going up, it's positive. If it's going down, it's negative. So when we look at this, I went up 1, 2, 3, 4. Okay? The way we count is we count as we move. We don't count. We don't say 1, 2, 3. We count as we move. We also don't start at the center when finding slope. The only time we start at the center is if we're plotting a point. Okay, so it went up 4. So I'm up at 4. Okay, it's on the top, and then it went right 1, 2, 3, 4, 5, 6. So it's 4 over 6. Okay? I actually meant that to be smaller, but that's okay. We can reduce this. So this turns into m equals 2 over 3. It's a bad 3. Okay? Now, one thing I will say is whenever you can reduce your fraction, that means that you have a point between the 2 points that you were just using. So instead of going up 4, if I went up 1, 2 and right 1, 2, 3, you'll notice we're in fact on that same line. Okay? And then you could technically use slope by continuing. I could still go up 2 over 3. And in fact, if you want to be super fancy, the opposite of going up and right is going down and left. So I could go down 2, 1, 2, and then left 1, 2, 3. And you'll notice I'm still on that same line. I don't know, it's not that straight, but you'll be on the same line continuously. Okay? So that's one example. We'll do one more. All right, so second example. Again, we're going to start on the left. Okay, so we're still going to have our m equals. We're going to start on the left. Okay, and right away, there's a couple things you should realize. It's negative because it's going down. Okay, and two, you're crossing over the x and y axis. That doesn't mean anything. Okay, you still count those. So when you go down, you don't go 1, 2, and skip over the axis and keep going. You count the axis. Okay, so right away, since it's going down, we can say it's a negative. Okay, and then we just count. It went down 1, 2, 3, 4, 5, 6, 7. So I have a negative 7. Okay, and then we know the bottom's going to be positive because it's always positive. After we went down 7, we went right 1, 2, 3, 4. And that will give me the answer. M equals negative 7 over 4. You can't reduce it, so that's your answer. Again, don't ever make it into a decimal. Okay, so that's it for today. There will be a practice on this that is just finding slope from a graph. It's not too bad. And then the next thing we'll do is a little bit more with slope, finding it from different ways, and something that's called rate of change. Hint, it's actually the same thing. Until then, I'll see you next time.